Problem 2 is another interest rate problem, but it's different in that in this case we're supposed to find the annual rate of interest. So they tell us that Cheryl's investment goes from 10,000 and it doubles up to 20,000 in 13 years. So we're going to put the 13 as the exponent. So we multiply by 1 plus the annual rate 13 times, and it goes from 10,000 to 20,000. So that, if you divide by 10,000, that tells you that you're actually just asking for the factor to be 2, to double the amount. It doesn't matter if she started with $1 and went to $2, or $1,000,000 and went to $2,000,000, or 10,000 and went to 20,000. All that matters is she doubled the amount. And if it takes 13 periods for that to do that, you want to take 2 to the 13th root of 2, which is dividing that factor of 2 into 13 factors. And each one is this, turns out it's 1.05476. Your calculator lets you know that. If you multiply by that 13 times, it's equivalent to doubling. And so the annual growth factor is multiplied by 1.05476. And that means the annual rate is the 0.045 or 0.05476, which is 5.5% annual interest. Problem 3 and 4 are just playing with the exponential and logarithmic form. And what I want you to remember is those are kind of relating the power of a base. So a base to a power is equal to some value. So in this case, in part 3, the base is a, which I've done in purple, and the power is 4t, whatever that means. It's just a made-up example, kind of manipulating these variables. But the power is 4t, and the value is 7x. And so we would change that to be the log base a of the value 7x is equal to the power 4t. And number 4 is just reversing it. We've got the logarithm base m, whatever m is, of the value 257 is equal to 9 to the r, or 9r. And so that 9r becomes the power of m. M to the 9r equals the value 257. And you can just manipulate those from the logarithm version to the exponential version. And in practical problems, we do that to figure out where the variable is. We want to get the variable out of the exponent. We make it we switch to the logarithm form, or we want to get the variable out of a logarithm, so we switch to the exponential form. Either way.